So I'll do 22 and 23 together, just because I want to. So in a test of the difference between two means below, what should the test value be for a t-test? And when they're talking about the test value for a t-test, they're talking about this formula. x1 bar minus x2 bar minus the difference in the means over s1 squared divided by n1 plus s2 squared divided by n2. Now you can do this in your calculator. I'll show it both ways. You can definitely do this in your calculator, right? Stat, again, go to test. This is a 2-sample t-test. Inputting those statistics, x1 bar, the first sample mean is 1520. The sample variance, whoa, they give us the variance. Now, if you remember the relationship between the variance and the standard deviation, so the variance is sigma squared is 400. Not sigma, sorry. S squared. So S is just the square root of that, which is 20. But the formula asks us for S squared. The formula actually uses the variance in here. The variance is the standard deviation squared. So we can just throw the variance in each of these and we'll be good to go in terms of the formula. If you're putting it into the calculator, I need this. You can even just put in the square root of 400 in there if you don't want to do the separate calculation. N1 is 8. Sample mean 2 is 1515. The standard deviation is the square root of 80. And then N2 is 16. Doesn't matter. We're just looking for the t-value. 0.6742 is what we expect to get. Or something close to that because of the approximations with the calculator. So let's see. So x1, 1520 minus 1515 minus 0, of course, over the square root of, now this is just going to be 400 divided by 8 plus 80 divided by 16. So 1520 minus 1515 is 5. In the calculator, I will input, let's go all the way down here, square root of parentheses 400 divided by 8, close parentheses, plus 80 divided by 16, close parentheses, 7.4162. 7.4162. So let's do 5 divided by that. 7.4162. 0.6742. We get the same thing. Yeah. That's our t-value. You can get it with the calculator, or you can get it using the formula combined with the calculator. 23. The critical value for a left-tailed t-test for dependent samples, when there are 7 degrees of freedom and alpha equals 0.025. Now the dependent, independent doesn't affect when we go to the table here, right? So degrees of freedom are 7 and alpha is 0.025, left-tailed, right? Left-tailed, 7, 0.025. One-tailed, 7, 7, 0.025. That's 2.365. 2.365. Now, if you think about that, 2.365. This here is 0.025. But this is right-tailed. If we wanted left-tailed, this would be negative 2.365. And that would still give us that alpha of 0.025. So this is negative 2.365. Symmetric.